Hey guys, this is just a recording of 6.1. I'm going to go do number 10 through number 18. The things we need to know before we begin, so that you might not have memorized, but that might come up, are the formula for the difference of two squares and the sum of two cubes and the difference of two cubes. Remember, squares just means that we have squared those two numbers. Two cubes means we have cubed these two numbers. And then sum means we're adding them, difference means we're subtracting them, okay? So if you have a perfect square minus another perfect square, you can reduce that or simplify that to the square root of a squared plus the square root of b squared times that square root again minus that square root, okay? The sum of two cubes, we have a perfect cube plus a perfect cube. So we're going to take the cube root of each of those, add them together, multiply it by a squared minus ab plus b squared. Difference of two cubed would be that a cubed minus b cubed becomes a minus b times a squared plus ab plus b squared. The other thing we might need to use is KFC. Remember when we have fractions like 1/2 divided by 3/4, what we do is we keep the first term, so that remains 1/2. We flip 3/4 to be 4/3, and then we change that division to a multiplication sign. Okay, so these are this is what you need to know besides how to factor in order to have success with 6.1. Okay, so KFC went how to flip the division of two fractions into a multiplication of two fractions. And then if you see something like this, translate it to this. If you see this, translate it to this. If you see this, translate it to this, okay? So let's start with number 10. It's actually not an easy one. We're starting with a hard one. So 3x squared minus 7x minus 28. Besides this, all we're doing is simplifying, okay? So to simplify a trinomial, we're gonna wanna turn it into, well, first take out anything you can, right? If we can divide all these by 2, we're gonna divide by 2, put the 2 out here. But then we want binomials, okay? Two binomials. So 3x minus 17x minus 28, I can't take out a 2, I can't take out a 3. There's nothing that I can divide 3 by, and I can divide 17 by, and I can divide 28 by and get a whole number, okay? So I have to go straight to this. I'm just going to focus on the 3x squared minus 17x minus 28 first. Remember that this is ax squared plus bx plus c. That has nothing to do with this, okay? I just like using a and b. So ax squared plus bx plus c is just a way to denote that the 3 is a, the negative 17 is the b, and the negative 28 is the c, okay? What we need to do to find this, if it's not very obvious, if I can't see it right now as I look at it, what I need to do is I need to find two numbers that are going to multiply to equal a times c, and that add to equal b, okay? Here our a is 3, c is negative 28. 3 times negative 28 is negative 84. Yeah, negative 28 times 3 is negative 84. Good. And then we're going to also add to equal negative 17. Okay. Now I want to find the factors of negative 84. Obviously, we have negative 84 and 1, or 84 and negative 1, right? We have, what's 84 divided by 2? It's 42. So we have negative 42, 2, right? We have negative 28 and 3. And remember, we're looking for two numbers that when you subtract this one from this one, you get a negative 17, okay? 84 divided by 4, we'll get 21, right? So negative 21, 4. We might have found it, right? If I take those and add them together, negative 21 plus 4, I get negative 17. So these are my two numbers that I'm going to put into, that I'm going to replace negative 7x with, okay? So I keep 3x squared. That one stays exactly the same. The negative 17 becomes negative 21 with the x plus 4x. It doesn't matter if these are in this order or flipped, minus 28. Okay, now because we have four terms and we can't divide it again, we're going to do factoring by grouping. So here's our first group, 3x squared minus 21x. I can factor out an x, right? I can also factor out a 3. So 3x squared divided by 3x leaves me with only x. Negative 21x divided by 3x leaves me with negative 7. 21 divided by 3 is 7. Just want to make sure. Good. And then we're going to, that's a plus. So we're going to add 4x and negative 28x. I can factor out a 4, right? 4x divided by 4 is just x. Negative 28 divided by 4 is negative 7. Good. Okay, luckily, we have x minus 7 as a factor for both of these. So I'm going to take that x minus 7 out. And then we're going to multiply it with the 3x and the 4. Okay, so 3x squared minus 17x minus 28 becomes x minus 7 times 3x plus 4. Good. Now we have to do that same thing with the bottom. The bottom should be a bit faster. The bottom was x squared minus 9x plus 14. Because I don't have an a that's higher than 1, I'm just going to try to, it should be easier. So here, a is 1, b is negative 9, c is 14, right? So it's going to multiply to equal a times c, or to multiply to equal 14, right? Because 14 times 1 is 14. And we're going to add to equal negative 9. So the factors of a positive 14. We know this is a positive 14, but this is a negative 9. So both of my factors have to be negative, right? So it could be negative 14, negative 1, negative, what's 14 divided by 2? 7. Negative 7, negative 2. And look, that works. Negative 7 plus negative 2 give me negative 9. So this becomes x minus 7, x minus 2. Good. So here we have on the bottom, x minus 7, x minus 2. Now you've done all the hard work. All that it remains to be done is simplifying. So anything that is common to both the top and the bottom can be deleted. And we are left with just 3x plus 4 over x minus 2 for number 10. Good. Okay. We pause this. All right, number 11. I just wanted to write it out so you didn't have to watch me write it out. It doesn't matter if this is in front or behind, so you can flip that and move it to the front because all the other a squareds in the front, however you'd like to do it. The first step is, well, let's just look at 15a minus 10a squared. Let's just look at the very first term, okay? Can I simplify that? Yes, both of these I can divide by 5a, right? I can take out a 5a. 15a divided by 5a is just 3. 10a squared, or negative 10a squared divided by 5a is negative 2a. Good. Or we can say 5a times negative 2a plus 3, whatever you feel more comfortable with. Okay, those are the same. On the bottom, we had 9a squared plus 6a plus 1. Here we're going to have to do similar to the previous, for to number 10, where we have to say a is 9, b is 6, c is 1, and we're looking for a number that will multiply to equal a times c, which is 9 times 1. So it needs to multiply to equal 9, and it needs to add to equal b, 6. Good. So what are the multiples of 9 that would add to 6? They're both positives? Yeah. 3 times 3, right? 3 and 3, multiply to 9, add to 6. So here, we keep 9a squared. Instead of 6a, we're going to say plus 3a plus 3a plus 1, okay? And then we're factoring by grouping. Our first group is 9a squared plus 3a. We can take out a 3a. We get 3a plus 1. Here we just have 3a plus 1. I can't take anything out, so I just say plus 1, 3a plus 1, right? So that's 3a plus 1 times 3a plus 1. Good. Or you can call that 3a plus 1 squared. So for our first term, we have 5a times negative 2a plus 3 over 3a plus 1 times 3a plus 1. Okay, now we need to look at this term, 6a plus 11, 6a squared plus 11a plus 3. I can't divide anything out of that whole, right? So what I'm going to do is a times c needs to multiply to equal a times c. It needs to add to equal b. So it needs to multiply to equal 6 times 3, which is 18, right? And it needs to add to equal 11. So what are my possible factors? Those are both positive, so I'm going to say both of the numbers are positive. It's either 1 and 18, that doesn't add to 11. 2 and 9, oh, that adds to 11, yay. So we have 6a squared plus 2a plus 9a plus 3. Good. 6a squared plus 2a, I can take out a 2a, right? And I get 3a plus 1. Here, 9a plus 3, so that's plus. I can take out a 3, so that's 3a plus 1. Good. So that becomes 3a plus 1 times 2a plus 3. Good. So that was up here on the top. 3a plus 1, 2a plus 3. On the bottom, I have 4a squared minus 9. Remember, sorry. Yeah, where is it? Way up here. 4a squared minus 9. Remember, if I have a perfect square here and a perfect square here, I can write it like this. So 4 is a perfect square, right? The square root of 4 is 2. The square root of a squared is a. So that's 2a. In this equation, our a value is 2a and our b value is 3, right? Because 3 times 3 is 9. And 2a times 2a is 4a squared. So that becomes 2a plus 3 times 2a minus 3, okay? Because of the difference of two squares. I'm just gonna write that here. 2a plus 3 times 2a minus 3, okay? Now we have all of that together. So we have 5a times negative 2a plus 3 times 3a plus 1. Oh no, times 2a plus 3 over 3a plus 1 times 3a plus 1 times 2a plus 3, 2a minus 3. I made it more confusing. I was trying to make it more clear, but it's super more confusing. Now all we're doing is like before, we're eliminating it. So we have a 3a plus 1, 3a plus 1, right? 2a plus 3, 2a plus 3. about that. So what we have left is, if I rewrite this after eliminating what I can eliminate, what we have is, I'll come all the way down here. How about 5a times negative 2a plus 3, which remember I just flipped those, so you can flip them back. 3a plus 1 times 2a minus 3. Okay, if I look at this, there's no 5a down here. Negative 2a plus 3 is almost, right? This one and this one are almost the same, right? We have a negative 2a, positive 2a, positive 3, negative 3. These two, there's nothing common to the numerator and the denominator, but these two are almost the same. What you can do is you can multiply either the top or the bottom by negative 1, okay? So negative 1 times 5a times negative 2a plus 3 over 3a plus 1 and 2a minus 3. Okay. So that means now you have, sorry, I totally explained that wrong. You can divide out a negative 1. All right. So we have this. We want this to look like this, right? If I divide negative 2a, or I multiply it, divide it by negative 1, divide it by negative 1, right? Then I will have positive 2a minus 3 with a negative 1 in front, right? Times 5a. So I divided out the negative 1 so that I was able to change the negative 2a to a positive 2a and the positive 3 to a negative 3. And then I keep that 3a plus 1 and the 2a minus 3. Good. Now I see I can divide out one more. I can cancel out these. And I have 5a times negative 1 is a negative 5a over 3a plus 1 as my final answer for number 11. All right, this is what number 12 looks like. I can divide out from 2x plus 2, I can divide out a 2. So that becomes 2 times x plus 1. The 6x plus 30, I can divide out a 6. So that becomes x plus 5, right? Because 5 times 6 is 30. Times 2x plus 10, I can divide out a 2 again. So I have x plus 5. Down here, 2x squared minus 2, I can divide out a 2. I have x squared minus 1. One more step with the x squared minus 1, that is actually the difference of two squares because x squared is a perfect square of x. And 1 is a perfect square of 1. So that becomes 2 times x plus 1 times x minus 1, because that's x is A, 1 is B. Good? All right, so if I put all those together, I have 2 times 2, right? 2 times 2 times x plus 1 times x plus 5 on the top. On the bottom, I have 6 times 2 times x plus 5 times x plus 1 times x minus 1. And you can put those multiplication signs between it, but the parentheses serve the same purpose, so it does not matter. Let's see what I can eliminate. This 2 and this 2, I can eliminate them, okay? X plus 1 and x plus 1, x plus 5 and x plus 5. All I have on top now is a 2. On the bottom, I have 6 times x minus 1. Good. One more thing I can reduce is, so I can call 6, I can either change it to 6 is 2 times 3, right? And then I can eliminate that too. I have nothing on top, but it's not a 0, so we call it a 1. 1 over 3 times x minus 1. That's my final answer for number 12, okay? 1 over 3 times x minus 1. Okay, number 13, we have cube, right? I see a cube. So I want to see if I can make the sum of two cubes. Is 3x cubed minus 81, are those two perfect cubes? You can take the cube root of 3, and you can take the cube root of 81. Neither of them are perfect cubes. However, sorry, that was a blur. However, I do know that I can take 81 and I can divide it by 3. Sorry. I get 27. So the first thing I can do with 3x cubed minus 81 is take out a 3. 3x cubed divided by 3 is just x cubed. Negative 81 divided by 3 we saw is negative 27. And then we can say, are those perfect cubes? So I know x cubed is a perfect cube. Is 27 a perfect cube? Yeah, because 3 to the third power is 27. Okay, so those are two perfect cubes, and we're going to do a difference because that's a minus sign. So here we're going to say A is x, right? And B is, the square root of 27 was 3. So B is 3. So now we follow this, leave that 3 out here from here. So that's just that one. A minus B is going to be x minus 3 times x squared plus 3x plus 3 squared, which is 9. Okay, I'm just going to go straight to 9. So the difference of two cubes turns x cubed minus 27 into x minus 3 times the quantity x squared plus 3x plus 9. So we're replacing this with all of that, right? So that becomes 3 times x minus 3 times x squared plus 3x plus 9. Now let's not worry about whether or not I can simplify this, okay? We'll just simplify the rest of them and see what we're looking at, because one of these two might simplify to this, and then I can just cross them both out, right? So 4x squared minus 4x minus 48, I see that I can divide all of that by 4. And I end up with x squared minus x minus, what is 48 divided by 4? It is 12. Okay. Times 8x plus 24, I can divide out an 8. And what I have is 8x divided by 8 is just x, and 24 divided by x, 8 is just 3. 6x squared plus 18x plus 54, I know I can divide out a 6. 6x squared divided by 6 is x squared. 18x divided by 6 is just 3x. And then 54 divided by 6 is 9. So you see how, because we did that, I can see that this on top and this on the bottom cancel each other out. Good. I'll rewrite this as 3 times x minus 3, sorry, times that 8. So I'll put the 8 out in front. It doesn't matter what order you put them in, but I'll put the whole numbers first. 3 times 8 times x minus 3 times x plus 3. On the bottom, we have 6 times 4 times x squared minus x minus 12. Okay, I told you not to worry about these two because they might be canceled out. This one wasn't, so let's see if we can turn it into something, turn it into two binomials and see if one of the binomials would be one of these two to cancel out further, okay? So we have x squared minus x minus 12. A is 1, B is negative 1, C is negative 12. So we want it to multiply to equal negative 12, add to equal negative 1, right? Negative 12, so it could be negative 12 and 1, or it could be positive 12, negative 1. It could be 6, negative 6 and 2. It could be 6 and negative 2. that doesn't add to -1. It could be 3, right? 3 and -4. Ooh, -4 plus 3 is -1. So it is -4 and 3. So x squared minus x minus 12 becomes x minus 4 times x plus 3 instead of that. All right, I'm going to rewrite it again. 8 times 3 is 24, right? X minus 3, x plus 3. 6 times 4 is also 24. And instead of x squared minus x minus 12, we have x minus 4, x plus 3. What can I cancel out now? 24 and 24, x plus 3 and x plus 3. So I am left with x minus 3 over x minus 4 for number 13. Okay. X squared minus 7x minus 8. I need a number. We need two numbers that will multiply to equal -8, add to equal -7. So we have -8 and 1, right? Does that work? That works. So we have x minus 8, x plus 1. Okay. On the bottom, we have 2x squared minus 128. I can divide out a 2, right? So that becomes 2 times x squared minus 128 divided by 2 is 64. Now I want to look at this. Difference of two squares. I know x squared is a perfect square. Is 64 a perfect square? So we just say square root of 64 is 8. So that means here we have the difference of two squares when a is x, b is 8, because the square root of 64 is 8, the square root of x squared is x. So now we write it as, leave that 2 out, a plus b times a minus b. Okay. So the first one, that first term is x minus 8 times x plus 1. Second term is 2 times x plus 8 times x minus 1. X squared plus 16x plus 64. I'm going to need two numbers that multiply to equal 64 and that add to equal 16. Let's just think about, we know that 8 times 8 is 64, right? And they add to equal 16. 8 plus 8 is 16. Okay, so this becomes x plus 8 times x plus 8. 2x squared plus 18x plus 6 is our last one. 2x squared plus 18x plus 16. I'm going to take out a 2 first of all. So if I divide everything by 2, I get x squared plus 9x plus 8. Yeah. Okay. Is there a way to turn that into a binomial? We need two numbers that multiply to equal 8 and that add to equal 9. 8 times 1, right? 8 times 1 is 8. 8 plus 1 is 9. So it'll be x plus 8, x plus 9. So let's gather those all up. We had, the first one was here, then there, and there, okay? So to write that all together, we have x minus 8 times x plus 1 over 2 times x plus 8 times x minus 8 times x plus 8 times x plus 8 over 2 times x plus 8 times x plus 9. Okay, you can rewrite it all as one, right? Since we're multiplying it, so it's just one big division bar. Let's see what we can cancel out. I see an x minus 8, x minus 8. I see an x plus 8, x plus 8, x plus 8, x plus 8. Good. So now on the top, all we're left with is x plus 1 over 2 times 2 is 4, x plus 9 for number 14. Oh, I'm sorry, I see a mistake. Okay, I said x plus 8, x plus 9, but it should be 1, right? So that should be a 1. So if that's a 1, that means these two cancel out too, and I just have 1/4 for number 14, real answer. All right, here's our first example with division. And remember, with division, we just need to use KFC, keep the first term, flip the second term, change from division to multiplication. So we're keeping 2x over 9. We're going to flip these. So 9x plus 18 on top, 4x plus 8 on the bottom, change it to multiplication. Okay, these are already simplified as much as they can be simplified. So it'll be 2x times, so I'm just going to put them all together. 9x plus 18, I'm going to take out a 9, and I get x plus 2, right? 9 times 4x plus 8, I can take out a 4, and I'm left with x plus 2. Okay, what can I cancel? I can cancel the 9, I can cancel the x plus 2, and I'm left with 2x over 4. 4 is like 2 times 2, right? 2x over 2 times 2. So it's actually just, oops, I'm sorry. It's actually just x over 2 as our final answer for 15. All right, 16, keep, flip, change. Change, flip. So this is just 8. This is x squared minus 81. Good. Okay. Let's take that first one. X squared minus 18x plus 81. I need two numbers that will multiply to equal 81, add to equal negative 18. So let's just think about 81 is 9 times 9, right? 9 plus 9 don't equal 18, but negative 9 times negative 9 do equal negative 18. So this is actually x minus 9 squared, right? You can also write it as this, okay? Next, we have x squared minus 7x minus 18. We need two numbers that multiply to equal negative 18 and that add to equal 7. So let's think about negative 18 could be 1 and negative 18, 2 and 9, 3 and 6. What is it? Yeah, 3 and 6. Is that it? Yes. Okay, so it could be 1 and negative 18, 2 and negative 9, 3 and negative 6, or negative 1 and positive 18, negative 2 and positive 9, and negative 3 and positive 6. Do any of those add to 7? This does, right? So we have x minus 2 times x plus 9 for this one. And then that's just 8. We'll leave it as 8. X squared minus 81 is the difference of two squares, where A is x, B is 9, right? So it becomes x plus 9 times x minus 9. So I'm going to rewrite that there. Okay, so what we're left with is x minus 9 times x minus 9 times 8 over x minus 2 times x plus 9 times x plus 9 sorry, times x minus 9. That's confusing because it's way over there. Ooh, I'll put it over here. Good, x minus 9. All right, let's see what we can eliminate. We can eliminate this one. Is that all? Let me look. Sorry, I miswrote that. So it should add to -7. So that should actually be +2, -9. So this is +2, and this is -9. Hopefully you caught that mistake before I did. So then I'm just not used to having that much to not eliminate. So it should look like that. So what we are left with is 8 over x plus 2, x plus 9. Okay, and you could refoil that out, but they're going to ask you to leave it in factored form. So I would just leave it like this. All right, number 17. It doesn't matter if you factor them out first or you flip it first. I'll flip it, pause it so it doesn't take, you don't have to watch. All right, so we kept, flipped, changed. Good, now we'll just identify each one like we've been doing. X squared minus 5x minus 24. Not identify, isolate and factor. Okay, so we need something that multiplies to equal -24, adds to equal -5. So we have 24 and 1, 2 and 12, 3 and 8. Ooh, 3 and 8 look like they might equal 5, right? Because it's a -24, it's going to be a -8, +3, or it's going to be a +8, -3, right? Which one would give us a -5? This guy. -8, +3. So x squared minus 5x minus 24 becomes x minus 8, x plus 3. Good. Next we have 2x squared minus 128. This is not the difference of two squares because 2 is not a perfect square. The square root of 2 is not a whole number. But I can take out 2, right? And I get x squared minus, what's 128 divided by 2? 64. And this is the difference of two perfect squares, right? Where a is x, b is 8. So it becomes x plus 8, x minus 8. We have to keep that 2 outside. All right, so on top we have x minus 8 times x plus 3. On the bottom we have 2 times x plus 8 times x minus 8. Over here we have x squared plus 16x plus 64. We want two terms that will multiply to 64, add to 16. We know that's 8 and 8, right? So we're going to say this is x plus 8 times x plus 8. Last one is x squared plus 11x plus 24. We know to multiply to equal 24 and add to equal 11. 24 is 1 and 24, 2 and 12, 3 and 8. 3 and 8 look good, right? 8, 9, 10, 11. So we have x plus 3 times x plus 8. So let's put that all together. We have our first term was x minus 8, x plus 3, then 2 times x plus 8 times x minus 8, x plus 8 squared, and x plus 3 times x plus 8. No. Okay. I'm gonna write it up. Good thing I paused the video because I messed it up again. Okay, x minus 8 times x plus 3 over 2 times x plus 8 times x minus 8 times, right, x plus 8 squared over, and since it's multiplication, I'm just going to put them all together at once and then eliminate. So we have an x minus 8, x plus 3, x plus 8, x plus 8. Ooh, we eliminated everything except the 2 on the bottom. So we'll just call that 1/2 for number 17. All right, our last one. X squared minus 9 is a difference of two squares where A is X and B is 3, right? So that becomes X plus 3 times X minus 3 over 6. X squared minus X minus 6 becomes X, two numbers that multiply to -6, add to -1. So we have 1 and 6, 2 and 3. If it's it could either be a -2 +3 or +2 -3. That one leads us to a -1, right? 2 times -3 is -6. 2 minus 3 is -1. X plus 2, X minus 3. Good. And then X squared minus 6X plus 9. We need two numbers that multiply to equal 9, add to equal -6. So it'll be two negative numbers, -9, -1, -3, -3, right? X minus 3 squared. So that was X plus 3 times X minus 3 over 6 times X plus 2 times X minus 3 over X minus 3 times X minus 3. Oh, sorry. Good. That's all one equation. So we're going to say that eliminates that. That does not eliminate anything. Sorry. That eliminates that. So we have X plus 3 times X plus 2 over 6. Good. And that's number 18.